Okay, we're going to test our knowledge of diffusion-controlled reactions. We're going to start with a very simple question. Are diffusion-controlled reactions fast? And the intuitive answer here is yes. But actually, this is a bit of a nonsense question. The rate is not the rate constant. It is the rate constant multiplied by the concentration of the reactants A and B. Okay, so I can't really say whether this reaction is fast without first knowing the A and B concentrations. Okay, so I could still have a diffusion-controlled reaction that is extremely slow. And I think that this is something that people overlook sometimes, that when you're talking about very low concentrations, a reaction that is slow could still be diffusion-controlled. Okay, so that's answer one. Okay, now answer two, we could go about this differently and say, well, let's compare a diffusion-controlled reaction in the liquid phase to a barrierless reaction in the gas phase. Okay, so if I go into the NIST tables and I look up how fast reactions in the gas phase are, I can find a few examples of things that are, for example, radical recombination reactions and things like that that shouldn't have any barriers, and I will find rate constants that are about like this. So they are reported usually in terms of Arrhenius law, and the typical value of A is going to be on the order of 10 to the 13 cubic centimeters per mole per second. And that, if I translate it into liters per mole per second, is going to be about 10 to the 10 liters per mole per second. The units here aren't particularly nice. Of course, there's no substance for which a mole fits into a cubic centimeter, but we're going to multiply these by very small concentrations in the gas phase, and that's going to correct for things. Of course, this all makes a lot more sense if you keep track of things as events per volume per time, but not very many people do. Now, we are assuming that EA is about equal to 0, and that makes this exponential term about equal to 1. So the value of the prefactor is going to be the value of the second order barrierless rate constant. Do that. Okay, so this is about the same as the diffusion controlled limit. And that is quite surprising.